Hello dear students, in this particular video we will learn force on a current carrying conductor in a magnetic field. बच्चों हमें पता है अगर कोई कोई वायर उसमें करंट फ्लो हो रहा है and if that wire is placed in magnetic field then it will experience some force. And how to determine the expression of force? Let's see. यहाँ पर हम लोगों ने y axis consider कर लिया. This is z axis, this is x axis and यहाँ पर we are showing conductor at this point in cylindrical shape. Okay, so let us say this conductor is making an angle of theta with y axis, and suppose the charge particle, let's say electron, which are free to move, they are moving in this direction. Vd is the drift velocity in this particular direction, so opposite to that direction will be the direction of current I. Now after understanding this, we know that force on a charge moving in magnetic field is given by Q V cross B. Here V is Vd and charge is minus E, and let us assume the magnetic field is pointing in y direction. This is the direction and this charge particle is moving in this particular direction. So we can say the force on each electron will be, since electron is charged particle, so this force is force on each electron small f equal to minus E Vd into B. Now if L is the length of the conductor and A is the area of cross section, then volume of conductor will be area into length. And if we consider small n number, n be the number of free electrons per unit volume. So total number of electrons in this volume. So total number of electrons in the conductor is you see in unit volume small n number of conductors, so in V volume n into A into L, where AL is the volume of the conductor. So this is number of electrons in unit volume और total volume क्या है AL, तो total volume से multiply कर देंगे तो number of electrons मिल जाएगा. Now total force on the conductor, यहाँ तो एक इलेक्ट्रॉन पर था, अब total force हम लोग अगर find out करें तो total force on conductor will be capital F is equal to इतने number of electrons है एक इलेक्ट्रॉन पे स्मॉल एफ लग रहा है, तो इतने नंबर ऑफ इलेक्ट्रॉन्स पे n इंटू एफ लगेगा. सो n इंटू एफ, और n की क्या है वैल्यू, इट इज NaL, और f क्या है, तो माइनस ई वी डी क्रॉस बी. So now we can take minus sign out, we can take this E outside. So this will become NeAl, and here it is minus Vd cross B. Now if we take a small current element of the wire, this is the wire, current is flowing in opposite direction, in this direction. If we take a small element dl, so idl will be pointing in this direction, but Vd is pointing in this direction. So minus of Vd will be in this direction. So minus of Vd is pointing in the direction of ideal, we can say. So if I take, and in current electricity chapter we have derived I is equal to NEA into Vd, right? So here I can say the direction of these two vector will be same, and if we multiply both the side, suppose this is minus Vd, minus Vd only, just write here, okay, at the bottom. So minus, take L also with this, L into Vd. Can we write Vd into L vector with plus sign? Because we are shifting the vector from Vd to L vector. So we want to just consume this minus sign. So minus of Vd is nothing but L vector. So now we have shifted the vector sign from Vd to L, correct? So this minus sign is getting removed. So we can write here NEAVD and L cross B. So this is nothing but the current I into L cross B. So I will repeat this point. Some of my students may face difficulty. Sir, what have you done here? So minus Vd, we know minus Vd is opposite to Vd. This was the conductor, Vd was in this direction. Now opposite to Vd is minus Vd, and this direction is ideal vector or dl vector or L vector. So minus Vd vector, if we multiply it, minus of L into Vd vector, can we not write Vd into L vector? Yes, because minus sign, minus of Vd in this direction and L vector, both are now in the same direction, and Vd, so no problem. So this is how we are writing. Let's erase this part, not needed. So finally we got the expression of force, and if you want to write the magnitude of force, we can write ILB into sine theta. Theta is angle between B vector and IL vector. Now if theta is 0 degree, force will be 0, since sine 0 degree will be 0. And if theta is 90 degree, force will be ILB sine 90. Sine 90 is 1, so force will be maximum, ILB. So when the conductor which is carrying current I, if they are placed along the magnetic field, parallel to the magnetic field, then there will be no force acting on them. बट वही कंडक्टर अगर 90 डिग्री एंगल पर मैग्नेटिक फील्ड के साथ रखा हुआ है, जैसे कि मान लेते हैं मैग्नेटिक फील्ड इस डायरेक्शन में है और कंडक्टर जो है परपेंडिकुलरली रखा हुआ है, तो दे विल एक्सपीरियंस मैक्सिमम फोर्स and direction of force by cross product. Okay, so the maximum force on this conductor will be ILV. So depending on the direction of placement or the angle of placement of conductor with respect to magnetic field, the direction of force will also the magnitude of force will vary and direction will also vary. So how to find the direction of force? For that we use Fleming left hand rule. Okay, we use Fleming left hand rule. What is that? If we stretch left hand के three fingers, first finger is thumb, second one is forefinger, and first thumb, second forefinger और third central finger. अगर ये तीनों fingers को हम 90 डिग्री पर प्लेस करें, ओके, तो after that what we need to do, first of all we have to stretch all these three fingers at an angle of at 90 degree angle, और ऐसा करने के बाद हमें अपने फोर्थ फिंगर को पॉइंट करना है इन द डायरेक्शन ऑफ मैग्नेटिक फील्ड, सेंट्रल फिंगर इन द डायरेक्शन ऑफ करंट, देन थंब विल पॉइंट इन द डायरेक्शन ऑफ मैग्नेटिक फील्ड. So let us write stretch the thumb and two fingers, that is forefinger and central finger of left hand in mutually perpendicular direction. Mutually now if the forefinger points in the direction of magnetic field, central finger in the direction of current, then thumb will point or thumb gives the direction of force on the conductor. Which on just for understanding, I am taking one example. Let's say conductor is in this direction carrying current I, and let's say this is y axis and this is x axis. This is the direction of magnetic field. So when you are stretching the fingers of your left hand, so central finger will go along y magnetic field will go along. So forefinger will points in the direction of magnetic field, central finger in the direction of current, then thumb will point in the direction of force. So force will be perpendicular to both I and B. So force will be equal to IL cross B. If we use unit vector for B, it is I cap. For this, it is J cap. So magnitude will be ILB 90 degree, and sine 90 is 1, and direction I cross J, it is K. So force will be in the K direction. So either you use unit vectors, take the cross product, or you can use Fleming left hand rule. So if you apply, if you will stretch magnetic forefinger in the direction of magnetic field and current in the direction of Y, then central finger, thumb is pointing in the direction of magnetic field, which is K. Okay. So I think in this video, whatever we have covered, the main idea was force on a current carrying conductor in magnetic field, and I hope you all could understand each and every point. So thank you, Michon. See you in the next video.